when you can begin. Check something.
Hey, hello, EthCC diehards. This is Lightning Talk session. Sajida, who is supposed to co-host, is still in a taxi, so I'm afraid you'll have to do it with me on my own. She'll come in later. Sajida is one of the organizers of ETH Paris, and she'll try to motivate you to still participate in ETH Paris. So Lightning Talks, how does it work? We have 12 speakers, meaning we need to be really disciplined. Speakers go through the slides really quickly, maximum 5 minutes, no questions. Actually, you can ask questions. There is a Lightning Talks back channel on Slack, so it's simply called Lightning Talks. And each presentation has a hashtag. Hashtag LO1, hashtag LO2. You'll see it at the starting slide. And if you just use the hashtag and ask the speaker a question, they can answer your questions afterwards. Because we need to be disciplined, there is a countdown. And I had actually hoped that there would be an extra screen here, so it's in that dark bag over there. I didn't manage to get the right cable. So what I will do is I'll position the countdown timer there. And when it's like 10, 8, 9, I will swing the timer in a dramatic way in your direction, and you will do the countdown. We can test it like 5, 4, 3, 2, 1. Yeah, that's how it works. And then you give a big applause, because there's quite some speakers here who do this for the first time, and we want to encourage this, so really be generous with applause. So, let's start. First up, we have Sheng Wang with Blockflow. Oh, speakers, so I will hand you the microphone, and you need to be positioned here for the recording between those two black lines. Go ahead.
Okay, tell me which one I should to switch the slide. Right. So, hello everyone. So today I'm going to present a novel sharding algorithm you probably never heard before. It's scalable, it's secure, and it's much more efficient and practical than the others. So as you probably know that sharding is really a very challenging problem. The main challenge is like the first one is cross-shard transactions. Usually you need locks. And the second thing is about scale smart contracts. So our algorithm Blockflow, we managed to attack these two problems in a practical way. At a high level, sharding is Blockflow is a DAO and a combination of DAG and the sharding algorithm. So the main advantage of it is first, the cross-shard transaction is really efficient. It needs just one step. The second thing is it's secure. It suffers from 51% attack. And we also have practical scaling solutions for smart contracts. The downside is that we need a little bit more space for the DAG data structure. And so how do we do sharding with Blockflow? The first, actually, we have two levels of, we have, it's not going to work. I don't know, can you go back? So we have two levels of sharding. Can you go back? Sorry.
Like this?
Yeah, can you go back because it's here. Sorry. We have two levels of sharding. First, we shard the RGS, and then we shard the transactions based on the input and output of the UTXO transactions. So let's say if we shard the RGS into 3 groups, in the end we will have 9 shards. In this approach, the cross-shard transaction is really fast. For example, if you want to transfer money from group B to group A, you just need to prepare the transaction and submit to the corresponding blockchain. We have a blockchain for each category of transactions. So here we have 9 chains We just need to choose the correct blockchain to submit it. The second advantage is like it's really scalable. So for example, if you are in Group B, you only need to download all the blocks that is related to Block B. You don't need to care about the transactions between Group A and Group C. So we all know that with sharding algorithm, usually it's much hard to reach consensus. So in our block flow algorithm, we have a specific sophisticated data structure to resolve the dependencies of shards. In this way, each new block actually defines actually decides a unique fork for each shard. In the end, it defines a unique for ledger for all shards. So I will not go into details. If you are interested, please read our white paper. The next big thing is about the smart contract, which is quite important for blockchain. So in our case, we first decompose smart contracts into token and the data parts. Both of tokens and the data, it could be easily scalable to work well with our algorithm. However, if for some of the applications, if you really want smart contracts like as powerful as Ethereum, then we still have something similar to this. We have 3 specific chains that have like that's like no different from the traditional blockchain. You can see that they are corresponding to red edges of the graph. Here we can really have a similar powerful smart contract like Ethereum. So combining smart contract with our token protocol and data protocol, you can really build very powerful applications. So that's an overview of our project. Unfortunately, I don't have time to go into details. But our project is not just about theory. We have already implemented the prototype of it. We tested it in AWS. We observed that the TPS could be as high as 10K. So if you are interested in it, please read our white paper. And also, we need the Scala developers and the Rust developers. So if you are interested, please reach out to us. We are really building the next generation and the practical infrastructure. Okay, thank you.
Excellent. Excellent. Up next, Dmitry. And I think we just leave the clicker here. There seems to be an incompatibility between PDF in slide view or in presentation view. You can just use the arrows on to the right. Just press, and since you're here, that should be okay. Okay, Dmitry.
Hi. Okay. Yeah. I would talk about rethinking current DApp architecture for better adoption and security. So if we see current architecture, it has 2 drawbacks. The first one, what you see is not what you sign. It's quite easy to see. If I would like to buy a kitty, I don't see the kitty in the wallet. And everything that I see in this particular example, only the price. But I don't see the image, I don't see the name. Essentially, I can't be sure that I sign exactly that what I would like to sign. And the second problem that we have, the page should be, or the DApp should be aware of Web3. It means essentially that we can't reach legacy sites like Twitter, Facebook, and so on. It's another huge problem. Why we have that problem? We have this problem, or those problems, because the very initial idea of Web3 was the simplicity. It should be easy to inject Web3 object and just implement with it, but it doesn't work. It doesn't work because of trade-off between user experience and security. It means every project that has focus on user experience, and should be almost every project, will sacrifice security for it, because project with focus on user experience will grow, and it's just not really auditable. We can trust the dApp, and that's why we should use wallet. And wallet has no any idea about context that it should represent. It just try to recover model and view from binary, and it doesn't work. So if we try to fix it, yeah, let's imagine how it should be. Just imagination. So if I would like to buy kitty, I should see the kitty. I should see the name, but I probably wouldn't like to see the history of the price. So it means I have to transfer some metadata into the wallet, but not all of that. If we can do it, then what you see is what is signed, it's perfect, and we can construct the transaction in the wallet, and it means the dApp won't be aware of Web3 object anymore, and it could be Twitter, and it could be any legacy site. So how it could work? If we click on Buy button, we transfer some metadata. Based on this metadata, wallet container will fetch dApplet from the registry. DApplet will fetch additional metadata, for example, image of the kitty from data storage, and it can display transaction, and it can construct transaction, binary transaction, and it can be signed. And audit and security. Because we have container in wallet, we can reject everything what smells not really good. Auditors can maintain audit status of the dApplet, and we can reject any data from data source which doesn't match the hash. It makes the things much more secure. And we can reach legacy sites. We can just inject one control into the site, and it will forward metadata to wallet, and then it will work. We can reuse Wallet Connect, and we don't really need MetaMask for this. Yeah, what we will gain? We will gain much better user experience and working what you see is what you sign principle. We can reach millions of users on legacy sites like Twitter, and we can build on the top of existing standards like signed typed data and Wallet Connect. Yeah, a lot of thanks for Pedro Gomez for Wallet Connect. A lot of thanks for Dan Filefo and MetaMask team. And for Sam Smith for Velociraptor meme, I like it very much. Yeah, thank you. Yeah.
Okay, excellent. It's like a 10-second game. Thank you, Dimitri. Up next is Thibaut. Time starts now.
Hi guys, so I'm Thibaut, and I'm gonna introduce you to the dApp we've been building called Multis. There we go. So we've been building Multis because we realized as a team how painful it is to manage your cryptos, to run your organization on cryptos. So by managing, I mean to access your cryptos, to manage them, and to actually use them, to fund your daily operations. So the solutions we have today, I think, are not optimal, and that's why we build Multis to help companies for that. The first option we had as a team was to use individual wallets. So say we raise funds, tokens, the option we have is to split them among funders, and hopefully no funder will run away with the money to the Bahamas and enjoy a quiet and peaceful life with caipirinhas. So that's the first option we have as a team. The second option we have is to use crazy expensive services, like the one provided by Coinbase, for example. You have to make huge deposits, you pay huge amount of fees each year, and you don't even have control over your funds. So as a team at Multis, this is a solution we don't really feel comfortable with, and well, actually we can't even afford it, right? And the last option we have are multi-sig wallets. So we have great tools out there, reliable, performant, but when it comes to non-technical users, like myself, for example, well, we think there is room for improvement in terms of UX, in terms of UI. And that's why we're building Multis. So Multis is a UX, a nice UI on top of a Gnosis multisig wallet that we want to make affordable for any organization, project of the community. So today we have a live project. You can actually use it, try it, give your feedback. I'll give you a special access code a bit later. So we have basic features to run an organization on cryptos. So you can manage your portfolio. So you have balances. You have the activity of your organization on the right side of the picture. You can add or remove counterparties, whether they are internal or external. Say you want to pay your freelance, for example, or giving tokens to any people of the community, giving a hand on the project. Well, you can obviously send and receive cryptos, so that's something you could expect for any kind of wallet. But then, and that's where it gets interesting, you can add or remove users on the wallet with specific rights. You can be either a guest, just read access. You can be a user with spending authorizations, or you can be an owner, setting the policies of the wallet, the governance layer of the wallet. And this is where you can set them when you are an owner. So basically, this governance is about how much I can spend a day, how much confirmations I need from other owners to spend a specific amount of money. And obviously, to change those policies, you need to be an owner, and you need to get confirmations from the other owners. So we really think that this project that we're using ourselves is going to be helpful for the community, for the projects, because we're really much focusing on the UX, on the UI. We're integrating existing and amazing protocols out there, and we provide obviously support because the idea is that we empower people to build all those great, crazy ideas, so that they can actually focus on them and not bother with managing the cryptos. We want to empower them because, well, I mean, like all of you guys, we think cryptos are going to change the world. And they're going to change the way business, corporations, associations work together. But to access to this new world, they will need cryptos. And at Multis, we want to be the gateway to these crazy ideas, to these crazy decentralized financial services that the community is building. So those are some examples of the protocols we want to integrate onto the platform. So you have amazing projects there. You have obviously the scheduled payment, exchange, on-ramp. Basically, all of these are new versions of legacy financial services, but in a decentralized fashion. But what excites us the most at Multis is all the projects that we do not know yet. I mean, the velocity of innovation in the space is amazing, and we are really thrilled about the idea to integrate those new services built by the community onto the platform. And that's why we need the community, first to build those amazing projects we're going to integrate, but also to provide us with feedback. So we really need feedback because we are a really young project. And you can join.
Excellent.
And use the access code there.
Excellent, thank you. Up next, Olaf. There you go. Thank you. Time starts now.
Hey everybody. All right, so let's start with the social proof. I'm an engineer since grade school. I've been working at Microsoft and Intel in Seattle. For the past 2 years, I've been working in the Ethereum space, building peer-to-peer lending, stuff like this. I was the first engineer at Civil, at Consensus, and now I'm running my own company and working with the Ethereum Foundation as a grantee. So, what is the problem? The problem is all the frameworks currently are not compatible in any way whatsoever. At Civil, we've been trying to fix this to make the truffle be able to compile with code coverage from 0x, and that took us 2 months and didn't end well at all. So this is pretty much comprehensive. So we've talked with the Ethereum Foundation, and we became a grantee, and for the past 6 months, we've been doing a solution to this problem. We call this solution the Resolver Engine. It's an API and a library for developers, for framework developers. How does it work? It's a tool for framework developers. It provides you with a singular API for any import solutions. It's decoupled and composed of those strategies, meaning you can mix and match. For example, we have different strategies for Remix ID, which is browser compatible, and different strategies for 0x and Waffle, which support file systems. Additionally, the library is abstracted enough that it allows you to support multiple different resolver things. So, for example, you could resolve calculations, you could resolve, I don't know, web pages, stuff like this. The API is very extensible and easy to add to. This is an example of how it works, and like pretty much you add this line and it works. That's it. And it actually is a solution. So we got it into multiple projects. 2 of those are already working. It's the Truffle Flattener from Nomic Labs and Waffle from FWorks. Summarizing, we have 11,000 APM downloads per week. And I think that's bigger than any other framework other than Truffle. We also have PR waiting for Solidity Compiler and Remix ID. Otherwise, the rest is still waiting, and we're happy to accept any PRs. In the future, we want to support versioning smart contracts. We want to have a common import standard that is defined by a test harness that can be easily used to check if your framework is compatible. And obviously, we're here to talk about more users. In terms of features for the long term, we would like to have a singular API for JSON artifacts, meaning you can mix and match artifacts and frameworks. So Truffle would be able to work with 0x, 0x would be able to work with Truffle, stuff like this. So how does it work? Well, obviously we need community to help us develop and actually use this standard. Otherwise, it's pretty much me standing here on the presentation. And thank you. That's pretty much everything from me.
It's like 1.5 minute one. Up next, we have David. There you go.
Thank you. Hello, I'm David Llop. May I go? I am David Llop, and I am a developer and a PhD student at the Universidad Complutense de Madrid, and I also work for the peer-to-peer models project. We research on decentralized technologies to promote, enhance, and preserve these common goods, such as knowledge. So access to information has been censored for ages. From King Dynasty to today, powerful have been trying to control the information citizens can access. Paraphrasing Aaron Swartz, information is power, and as all powers, there are those who want to keep for themselves. So in China, the Inquisition and the Third Reich, the books were burned, and nowadays, the pages are censored. Barlow's declaration of independence of the cyberspace was pretty optimistic. It said that it didn't matter where we were from. In the cyberspace, there was no barriers, and we all shared a common citizenship. But why it didn't work? Why are still things that are being censored? This is because that cyberspace is not that ethereal. It's made of cables and machines. And as any cable and any physical machine, the governments can put their hands on. So as the internet infrastructure is quite centralized, it can be censored. For example, police can switch off the Pirate Bay server. A DNS company can withdraw wikileaks.org domain name. Google can uninstall an application from our own mobile phones. And also, the whole internet can be shut down, as in Egypt in the Arab Spring. In 2017, Wikipedia was blocked in Turkey because it could extort the ISPs in their national territory. So the Wikipedia IPs were blocked. 1 week later, the IPFS team released that note in which they say that they had put a snapshot of Wikipedia on IPFS, which is a distributed peer-to-peer network. So any node could distribute Wikipedia pages, and the IP block could be circumvented in that way. That is a huge step for decentralization and censorship resistance, but it has some drawbacks. For example, it still relies on DNS or on a non-human-friendly hash. It is not editable from within the web page, and only a single party can publish updates. Blockchain could help on that by providing an ENS name, and also multiple parties could edit with permissions, and a governance system could be put inside a DAO, for example. Also, it has their drawbacks. For example, the gas costs of each edition, and also the incompatibility with the current browsers. And this is what we did at peer-to-peer models. We have developed an IPFS and blockchain-backed decentralized wiki on top of Aragon. It can be edited within the web app, and it has many pages, and each page can be protected by permissions. So it is a free and open source project, so you can use it for your own projects. You can propose improvements, and you can use it to change the world. And if you want to stay in contact, here are the web pages. Thank you.
Excellent. Extra big applause for that extra 10 seconds. Up next, Gonzalo. There you go.
Hey, can you hear me? Yeah. Okay, I'm going to talk to you about the proof of attendance protocol, POAP, that we pronounce as in Pope Mobile. And Lambo's jokes still work in a bear market. Or not, do they? So the proof of attendance protocol is basically, it's something we built at the Denver Hackathon. It's a standard and an implementation for event organizers to give badges to people that show up to their events. So we built this in Denver. I have the physical proof of attendance here. This wasn't an invention that we came up with. People have been doing this for a while. Like Piper Merriam did a version in DevCon 2. People have been giving these Ether cards at other events. You've probably seen this if you've been around the Ethereum Roadshow. And this is a Buffycorn, which is the non-fungible that you got when you went to ETH Denver, because it's like half a buffalo, which is a thing in Colorado, apparently. What we did is a nicer version that people can actually use to issue these things easily, because what happened in the past is that only the huge events have it, because they have the extra manpower to be able to figure it out, like create the NFTs, give it around, and et cetera. And then they're hard to collect because they're not really compatible with each other. So, well, of course, the DEFCON 1 ERC 721 didn't exist. So basically, now the technology is there to make a sustainable version, which is what we built. So there's essentially an easy way for organizers to give it away and an easy way for people to collect them. So if you're organizing an event and you want to use Pope, basically you talk to us and we set you up, say you're doing a literature conference. There's many ways to get your badges. One of them is you set up a Raspberry Pi on the premises, and then people have a local URL that they can go into and basically get an NFT by signing a message. We just basically we pay for the gas, and you get the NFT in your wallet without having Ether in it, which is pretty convenient. There's the classic find a volunteer or someone in the organization, airdrops it to you by scanning your wallet and sending the NFT your way. Or if the event gets addresses from people that show up. So if you signed up using a wallet, or if they require that when you sign up for the event, the classic airdrop of tokens also works. This is live on mainnet. We built this 2 weeks ago in Denver, maybe 3 weeks, I don't know. There's over 200 NFTs. We've been giving these away also for this event. So if you want to have your EthCC 2019 badge, you can either reach out to me or to my friend that's wearing red, and we'll give you a badge. And we're also going to be at ETH Paris, and we're probably going to work on this. It's ERC 721, so it's compatible with OpenSea or anything that uses ERC 721. If your wallet is like, many wallets support this, but others don't, so this is a good opportunity to find out whether your wallet is collectible compatible. Trust, for example, that is, I think, the one there, works just fine. And the components are PopeScan, which is essentially the Etherscan for this. Essentially, you put in a wallet, and it shows you all the events that you've been to. And there's PopeClaim, which is the Wi-Fi Raspberry Pi thing that we tried to set up, but in December we had complications with that, so that didn't really work. That's probably what we're going to work on tomorrow in ETH Paris. It's an open source thing, community, basically no one intends to make any money out of this. We're not selling tokens. And in the future, we like this because we think it's a cool use case that everyone here can possibly relate to. Like, you can get your badge right now and you can have it. And it's an easy way to start getting acquainted with collectibles and basically ironing out these adoption details, which are your wallet doesn't support it, you never used it, your wallet doesn't transfer it. There's a lot of shenanigans, and this is a cool way to get it going. That's the URL. It explains everything that I just said in writing. You can contact us. That's a Twitter handle, but there's also a Telegram channel that you can join to ask for your badges. And that's about it. Thank you.
That was 20 slides, 4 minutes, 300 words per minute. Up next, Tim. And you have to realize this is a bit of a blind date, so most of the people I actually never met and only interacted via Slack with. So there you go, Tim.
Hello, hello. Hi. Show of hands who remembers this. So yeah, that was basically, for everyone that doesn't remember it, it was the Parity Hack, where someone actually accidentally called the constructor of their multisig wallet and I think destroyed a bunch of millions of dollars, I think. We think that there is a problem in smart contract attacking today, where there is no real communication going on between the contract owners and the attackers. There's also no standardized way of like engaging with someone that has a vulnerability in the smart contract. And then what happens is that the contract owner basically loses all of their credibility, the users lose all of their funds, and the attacker, even if they may get the funds, they might get like delisted from exchanges or like blacklisted from exchanges. So they might not even able to spend those funds, right? And that's why we started to work on this project, which is called 0x Deface Me. And it's basically an Ethereum improvement proposal to settle smart contracts fairly in case they have vulnerabilities. Now, I'm going to go a bit into detail how this works, but it's, I think like the time doesn't permit it too much. So essentially what you do with your smart contract, if you're a smart contract owner, is you implement the EIP that we give to you, which is not yet released, but we have a white paper. But you implement basically the interface that is set out in this EIP, and it's roughly 7 functions right now. And then when an attacker finds a vulnerability in your smart contract, what they can actually do is they can talk to the negotiator, commit a vulnerability, and with a public cryptography scheme, they can basically commit and reveal that vulnerability. And if it happens to be that you as the contract owner pay a bounty to the attacker, then it can be done where you can shut down your smart contract in a controlled manner. So you give basically the funds back to the users, and you pay out the attacker a small bounty, basically. So like, I don't know, like 10% of the contract's balance or something like that, or even less or more, or we'll have to see, I guess. There's a demo on our website, so it's www.0xdefaceme And what you can do, it's currently deployed on Rinkeby. You can take the exploitable, commit a vulnerability, put your damage in, and basically I am currently the centralized smart contract owner. There can be also like decentral, like there could be multi-sigs, for example, as contract owners, or an Aragon agent. And so if you do that, then I will read the vulnerability probably, and yeah, maybe you get like a Rinkeby Ether. Right now, we're mainly looking for feedback and for grants. We're trying to build this like as a common good for the Ethereum network. And yeah, I mean, we have a white paper. It's pretty early. Like I think we started this 2 weeks ago or something. So yeah. So yeah, that's deface me, a standard to settle Ethereum smart contracts fairly in case of vulnerabilities. Check out our white paper. And yeah, thank you.
Excellent. It's 1.5 minutes. Up next, Tas. There you go.
Thank you. All right, that was awesome. So I'm going to talk about dominant assurance contracts. A dominant assurance contract is a variation on crowdfunding, which helps to solve the free rider problem in crowdfunding public goods. So, so first of all, crowdfunding, you've heard of Indiegogo, Kickstarter, GoFundMe. People raise money in small amounts from lots of people. The problem if you're funding a non-excludable public good, such as open source software projects, is that each individual, their optimal strategy is to be a free rider, meaning to sit on the sidelines, let other people pay for the project, and then get the benefits without paying for it. So how do you solve this? Dominant assurance contract is a variation on crowdfunding assurance contracts, which introduces a refund bonus that's paid out to contributors if the fundraising goal is not met. So if you contribute to a project and the project succeeds, the money goes to the project, they do the project. If the fundraising goal is not met, let's say you have a $10,000 fundraising goal, but only $5,000 is raised, all the money is refunded to the contributors, plus a bonus of say 10 or 20%. So if $5,000 was committed, then the 20% bonus, $6,000 is refunded to the contributors. What does this do? This increases the incentive for participation and reduces the free rider incentive. I'll explain in a second. The refund bonus could be provided by either the project organizer or by a third-party investor. This was first described around 1998, and it's been studied by a few academic groups and discussed by a few people, but as far as I can tell, nobody's actually tried this in the real world, and I think it should be tried. So a simplistic look at the incentives with regular crowdfunding, if you think the project is valuable, like you want it to get done, and you think the funding is going to succeed, your optimal strategy is to be a free rider. Don't fund it, let other people pay for it, and just get the benefit. If you value the project and you think funding will fail, your optimal strategy could be to not fund it and be a free rider if it succeeds. Or maybe you want to push the project towards getting funded and you want to be you want to contribute to it because you think it's going to fail, but you want it to succeed. So it's a little bit unclear. If you think the project is not valuable, then you shouldn't fund it. With a dominant assurance contract, the incentives are a little bit different. And this is a simplistic view again, but if you value the project and you think funding will succeed, you might free ride and get the benefit still, or you might fund it in case you're wrong about the success of funding, and in that case you get the refund bonus, which is free money to you. If you value the project and you think fundraising is probably going to fail, then you should definitely fund it because you get the refund bonus, which is just free money for you. And if you're wrong and funding succeeds, then you get the benefit of the project. So it's either way you win, it's a win-win. If you don't value the project and you think funding will succeed, don't fund it. But if you don't value the project and you think funding will fail, then you should definitely fund it because you get free money back. So this increases, it's not like black and white, but this increases the number of cases in which people are incentivized to participate in the crowdfunding versus a regular crowdfunding assurance contract. So what kind of projects is this suitable for? Well, open source software, infrastructure projects, non-excludable public goods. Ideally, straightforward engineering, not open-ended research because it's hard to quantify the time and cost for that. You want something with an easy-to-understand value proposition that is valuable to, has a significant value to a large number of people that you can market to directly, easily addressable audience. You want the team to be able to market well. So anyway, I think this is an interesting idea. If you know of a project or you have a project that you think would be a good candidate for crowdfunding with a DAC, or you're interested in helping to build the software to run a DAC, please contact me.
I think this was the record. Marius. See, you caught the next speaker off guard. There you go.
Thank you. Hey, hello everyone. I'm Marius, and today I'm going to talk about resolving non-attributable faults in data exchanges. It's not like the most, not the topic that you would normally talk about, but yeah, we don't care about this. Data exchange. So if you want to pay for data with money, then there's a big question. Who pays first? Or who sends first? Do I first send the money and then get the data? Or do I first send the data and then get the money? Or, and there's an inherent fault in this, which is called a non-attributable fault, because you can always claim as that you did not send, that the other party did not send the data. So my slides are a bit wrong there, because that you did not send the money is the transaction is recorded on-chain, but the sending of the data is not recorded on-chain. So there's a fault there, because someone can just claim, okay, he did not send the money, he did not send the data, but he did send the data. So and you cannot attribute this fault to one of these parties. And I created a new protocol, which is based on another very new protocol from a colleague of mine called FairSwap. And currently starting some startup, I guess, or some NGO, which is called Saucy, which is about this trustless data exchange, and you can pay for rumors, and it doesn't really matter. So I wanted to give you a high-level introduction into this protocol, because I think it's for every developer a valuable source. And so the idea is, you want to send money, so Alice, you want to send data, Alice wants to send the data to Bob and wants to get paid for it. So she adds a new data source to the smart contract. She sends the encrypted data and the hash of the key which she used to encrypt the data to the smart contract. So this is like the first thing. And this encrypted data, it doesn't have to be stored on the blockchain. It can be stored on like IPFS or something like this. And then Bob can say, okay, I want this data. I'm now going to bid on it, and I generate a key, key prime, and send the encrypted key prime to the blockchain, and also put the hash of key prime on the blockchain and send some money. The money gets locked into the contract, and now Alice can say, okay, yeah, I want to sell this data to you, and she generates a one-time pad, which is, well, basically we use the key that Bob provided as a one-time pad, and XOR share it and generate this key double prime, which is the XOR share of key and key prime, and we send this to the blockchain. Now what Bob can do, if he feels cheated, he can now recompute key by XORing key prime, prime, and key prime, and decrypt the data. What happens if Alice sends the wrong key? Then Bob can send his key prime to the smart contract and dispute the exchange. And in this case, the smart contract checks whether the hash of key prime equals to this X, the hash that Alice provided earlier, and whether the XOR of key prime and key prime prime equals the Y. Yeah, and this is the FairSwap protocol. The original protocol is a bit more elaborate in a way that you don't not only share the encryption key, but you share the whole data and only put the Merkle root of the data onto the smart contract, and then you can provide a Merkle path to this fault verification function. Okay, thank you for your attention, and if you want to read the papers, they are all on Perun.network.
Thank you.
Excellent. You can switch to the next one. Good. Up next, Max. There you go.
Hi, everybody. My name is Max from Geo Protocol. So, what we really do? We are developing off-chain open source protocol for providing a multi-hop fast transaction in distributed network of nodes with different assets. I mean, including crypto assets and, for example, fiat money and some custom solutions such as kilowatt of energy, for example. Why we really do it? Because of limitations of siloed ledgers. I mean, for example, traditional finance institution is slow and with high cost. And what about blockchain? We know limitations also, efficiency, limited scalability, and throughput. So, actually, our aim is to create universal protocol to connect different network of values, such as some kind of transport protocol, such as TCP/IP in internet. So, how does it work? Protocol by design is very simple. There are two main elements. There are nodes and links. There are not nodes supporting some kind of blockchain register. There are no common ledger. You can imagine a huge network of nodes. There are different nodes with different data and with different assets. So nodes can establish links by protocol. There are two links in our protocol: trust line and state channels. Trust line allow to provide multi-hop payments in distributed network by accounting IOU. And when we talk about state channel, it can provide trustless payments with crypto assets. So it's our ecosystem. So there are just four main algorithms. For the first one is routing algorithm, which provides the possibility to get information about existing passes between two nodes in network. And the main feature is that we don't use some kind of coordinator which collect all topology of network. So then a maximum flow prediction based on a routing algorithm which provide a possibility to get information about maximum amount of asset which sender can send to receiver. And payment algorithm, and the key point is that there is no common ledger, there is no blockchain register, so we use local consensus. We call it local consensus because of transaction provided by collecting signatures only of the participants of transaction. So we use, by the way, quantum resistance cryptography, and there is limited time. So I can say we are developing for 3 years, and finally last week we already launched beta version, so you can congratulate us. Yeah, thanks. And we invite the community to try launch a node and to test it, and we will really appreciate your comments and feedback. Thank you very much.
Excellent. I'm not sure whether you have noticed, we started like past. We're 50 minutes in, we've had 10 speakers, so everyone is really disciplined. We have room for 2 more speakers. So up next is Eric.
Thank you.
Just keep to the right. This one.
Ah, okay. Okay. I'm Eric Burgel, CEO of P2Expand. We are a video game studio. Okay, what is the goal for a video game on the blockchain is to be trustless, obviously, real-time if possible, and scalable. So how it is today, everybody knows that, for example, CryptoKitties are on the blockchain, but where are the images of the CryptoKitties? It's on a private server, of course. So what is our simple proposition is to have a standard format for the data of the asset. So it's to have a container file which all the images, all the data of the asset, which is signed by the creator of the asset, and we can have the asset in the standard. I'm sorry. So we have called it a BBA for blockchain bin asset. And we can store it on local machine or on IPFS, for example. So what can we do with it? Of course, we can still download from a server and use it in your application after having verified that the signature is okay. But in another case, you can two users can exchange data about the asset they own. It's nothing to do with the ownership. Okay, it's just to exchange images or 3D models or sounds of the asset, and they can do it even if they are downstairs in the bar and they haven't got any connection. Okay, they can still verify the signature to be sure that the asset is legit. Okay, it can lead to scalability because if you have 1 million users, they can still exchange data about the asset even if the server are down. Sooner or later, the server will be down if it's centralized. Okay. And if the standard is widely adopted, it can lead to have a better understanding of transaction on the blockchain, because you can decode the transaction to show the image of the asset, for example. We have already made a visualizer, which you can drop your BBA on the visualizer, and it will show you the description of the asset, the image, even the 3D model if it exists, and the signature of the company. Of course, you can use it to put other kind of asset. For example, a diploma. When you have somebody which apply for a job, he can give you his BBA diploma, and you can verify easily that it's it's legit. Okay, what is the value of our proposition is it's simple, it's blockchain agnostic, it's completely storage agnostic. It can put it on the IPFS or locally or on server. Okay, we have made a Medium article about it, and you are free to check it. Thank you very much.
Okay, those damn speakers, they actually don't let you do the countdown. Is Elias Haas in the room? Oh, you are. Oh, where'd you come from? There you go.
Thank you.
Over here, Elias.
Oh, over there. Okay, cool. Right, I'm going to keep this super simple. There we go. I'm Elias. I'm one of the founders of B9 Lab. We've been training training developers and others on blockchain for the past 4 years, which means we are absolutely ancient. And we have started a new program this year where we're aiming to train 1,000 developers for free on Ethereum, and we need help with that. So we've been working with sponsors. The first cohort starts on the 18th of March. The whole thing works like we've put the call out and people can apply, so developers can apply to be admitted to the program. They have to go through a coding test, and we then pick the best of those. We already had 1,400 applications from like 100 countries. A lot of people super excited to get into this industry. So if you are either very wealthy and you want to support a lot of people, or you are part of a project that needs to get their tech in front of developers, or you want to hire, or you just want the exposure, get in touch with me. We are looking for more sponsors to get more people through. I think we've now got enough sponsorship to do the first 150 to 200 people, but obviously anything helps. So if you want to be part of this and you want to help us get more people through, go there, contact me, talk to us. Or alternatively, if you're a developer and you want to actually go through an in-depth mentored Ethereum course, then go and apply, take the test. And you know what? That's it.
Okay, so that were 12 speakers in less than an hour. If you like the format, you've probably seen this link that I've been pushing in Slack. You can just copy the text, and if you organize your own conference, you can just copy the format for your own lightning talk session. I actually did the same. This is a format that's been used at German hacker conferences. Some of the speakers of last year, they actually came back in the main program of this year, so I hope this happens again. So thank you to all of the speakers, thank you for attending. See you next year, or maybe see you at the after party or at the hackathon this weekend. Thanks, bye.